Okay, I decided I was going to just do a short little PowerPoint for you to explain this answer. So we're going to look at aluminum plus sulfuric acid forming hydrogen and aluminum sulfate, double replacement reaction. I mean, single replacement reaction. So, okay, so let's go. First of all, the word equation is aluminum plus sulfuric acid yields hydrogen. Okay, so aluminum plus hydrogen plus aluminum sulfate. First thing you need to do is convert the names to formulas. Okay, so aluminum is Al. Remember, all elements that are all by themselves have a zero charge, so we put a zero up here. Sulfuric acid, the key to sulfuric acid, one of the keys is to change it to its ionic name, and I went over that. So this would be hydrogen sulfate. Okay, and then what we want to do is write in its ionic form. Hydrogen, so we're going to write it like, so we're going to start it out like this, H plus SO4 2 minus. Hydrogen gets a plus charge. You treat it, it's in the first column. So when an acid, when you have an acid, the H behaves like a metal from the first column. So it has a plus charge, just like sodium, potassium, so forth. Next thing, you have to make sure the charges are balanced. All right, so you have a +1 charge here and a 2 minus charge. So crisscross charges. So you get a 2 here and a 1 here. But you know you can you don't need to include the 1, and so we get this. Okay, so this is going to be sulfuric acid or hydrogen sulfate. Technically, we call it sulfuric acid, but hydrogen sulfate helps us figure out its name. You can look at that in the name of the formula. So if you change the sulfuric acid to hydrogen sulfate, it'll be aluminum plus hydrogen sulfate yields hydrogen and aluminum sulfate. Okay, so you can see how the names swap. Okay, so again, if you had aluminum, a sloppy way of writing it, aluminum plus hydrogen sulfate, okay, is going to give you hydrogen plus aluminum sulfate. Okay, so changing it to its ionic name right at the beginning actually helps figure out the product as well as the how to write it in formula. Okay, the third substance is hydrogen. And whenever hydrogen's an element, hydrogen, when you write it, is not a single element like aluminum. So there's two of them. It's a diatomic molecule, and again, it has a zero charge. Okay, so it's H2 with a zero charge. And aluminum sulfate. Okay, well, aluminum has a 3 plus charge, and we went over that when we went over ionic compounds. Sulfate is SO4 2 minus. Okay, since the charges aren't the same, you have to crisscross. So now this becomes a 2 over here, and this becomes a 3 over here. And we get this right here, Al3 2, SO4 2 minus, SO4 2 minus 3. Okay, so if you notice the charges now equal but opposite. 3 times 2 is 6, 2 times 3 is 6. Okay, so we all have all our substances. Let's put them in a initial chemical equation. All right, so we got aluminum plus sulfuric acid or hydrogen sulfate yields hydrogen plus aluminum sulfate. Okay, this is not a balanced equation. If you notice, there's 2 aluminums on this side, okay, and so forth. All right. So when I balance single replacement reactions and double replacement reactions, for the most part, I usually start out with the substance that has the most subscripts. Okay, it just tends to work, and so I have this guy over here has 3. This one has 2. There's no, I mean, this is not a law. It's just helpful. So, I'm going to start out with aluminum sulfate, and specifically, I'm going to start out with the sulfate. Okay. So I notice there's 3 sulfates on the product side, and 1, because technically there's a 1 over here, sulfate on the left side. All right. Okay. So now I have to get the same amount on both sides. There's actually, you can put a 1 in front of here as well. Okay, so the number of each substance is the number in front times its coefficient. So 1 times 3, so there's 3 altogether over here, so I need 3 sulfates. So I need 3 sulfates on this side as well. Well, 1 times what number right over here is going to give me 3? Well, obviously it's 3. Okay. So now I have, no, I can't do that. I can't put it down there. Sorry, I have to put it here. If I put it here, I'm changing the whole formula, okay? All right, so what we're doing is we're figuring out what numbers to put in front. So I get a 3 here. Okay, so now I have my sulfates balance. Now what I like to do is I like to stay with, so I'm right here. Okay, so what I did is I moved from here to here. And now what I'm going to do is look at the hydrogen. Okay, so I have, now if I look, I see that I have 3 times 2 hydrogens over here. And right now, 1 times 2 hydrogens over on the product side. Okay, so what number do I have to put here? So 3 times 2 is 6. So what number times 2 is going to equal 6? And obviously x is going to be 3. So I'll put a 3 here. Oops, that should be a 3. Okay. All right. Okay. So now I am right here. All right. Okay. So now, let's move forward. So let's change this to a 3. Okay. So now I have the sulfates are balanced. And I have 3 on both sides. 1 times 3 and 1 times 3. 1 times 3. That's fine. My hydrogens are balanced. 3 times 2 is 3 times 2. And the only thing left is the aluminums. I see that I have 2 aluminums on the product side and only 1 over here. So what number do I have to put in front to give me 2? Well, 2. Okay. And there's the balance equation. Okay. 2 aluminums, 3 sulfuric acids, 3 hydrogens, and 1 aluminum sulfate. Okay. Hopefully this helps. Okay, so when you start out with the thing with the most charge, okay, specifically, I mean the most subscripts, and specifically the negative ion. Okay, then come over on, then go fix it on the other side. So you need to put a 3 to give you 3 sulfates on both sides. Then stay over here and count how many you got of the other substance, in this case hydrogen. So you have 3 times 2, 6. So then come over and fix it on the other side. So what times 2 is 6? Put a 3 here. And then lastly, take care of the last substance, which is aluminum. You have 2 on this side, so you have to put a 2 over there. Okay, I hope that helps. If it doesn't, please let me know, and we'll work with it. Okay.